Whenever S is N, S interior empty set. S is Z, S interior is empty set. Try to remember. But follow the arguments. Next one. If S equal to Q, we have seen rational number system, no point is interior point. So take next one. If S is equal to Q, S interior is empty set. Because no interior point. Next one. If S is equal to R minus Q, S interior is empty set. Because no irrational number is interior. Next. If S is equal to finite set 1, 2, 3 and so on up to n. If S equal to 1, 2 and so on up to n, remember S interior, note down this. It is not there in the document, you have to note down. If S equal to 1, 2, 3 and so on up to n, S interior is empty set. Why? Because no point of it is an interior point. If you take any point, then if you take a neighborhood, it contains decimals. This does not contain decimals, so that point is not there. S interior is empty.
Empty set.
A set which is in the neighborhood of every point is R.
Sir.
You know that if whenever you take R,
No.
any real number P minus epsilon to P plus epsilon is contained in R. What is R means? Minus infinity to plus. This interval around P is totally contained within this. Therefore, we say that every point P is an interior. Next, R minus N. What is meant by R minus N? R minus N means all real numbers except natural numbers. That means minus infinity to infinity. N, 1, 2, 3 and so on. N means 1, 2, 3. What is R minus N means? Complement. What is in the complement? Remove N, remove 1, remove 2, remove 3 and so on. Then how will you write? How will you write this set? R minus N, minus infinity to 1, all are included. Minus infinity to 1, all are included. 1 is not included. Again, you have to remove 2, but in between they are there. You have to remove 3, in between everything is there. How will you write? R minus N. Want to take down this definition. What is meant by R minus N? All real numbers other than natural numbers. What are natural numbers? 1, 2, 3 and so on up to and so on. There is no end point. So how are we going to write R minus N? Minus infinity to infinity, 1, 2, 3 and so on. You remove 1, remove 2, remove 3 and so on. How will you write this? This is equal to, note down R minus N is equal to minus infinity to 1. All real numbers included. Union. 1 is not there, 2 is not there, but in between is there. So 1 comma. Union. 2 comma. And so on. What is the last natural number? Let us say n. Then union, last one, if you say, and so on, union, n comma infinity. N comma infinity. What is n? The last natural number. What is that? We don't know. That natural number comma. So what is R minus N means? It is union of open intervals. Which open intervals? Minus infinity to 1, all. 1 to 2 in between, 2 to 3, and so on, and 3. If it take the union of all, then you get R minus n. Then you know that if in case of a open interval, every point is integer. In case of open interval, every point is integer. Here also every point is integer point. So for R minus n, what are integer points? Every point of it is an integer. Therefore, R minus n is also an example of a set which is having every point of it as an integer. Okay?
Ma'am,
Uh,
minus infinity to 1 is closed interval.
Minus
Included
infinity.
1.
No, 1 is not included, 1 is open. Because 1 is natural number, we cannot include. Write down this point. Write down this point, all of you. R minus n. Very important. Often we will be coming across this. Then you remember this. What is R minus n? Minus infinity to 1. 1 is open. 1 is not included because 1 is natural number.
Here you can write closed number minus infinity. Okay, that.
Minus infinity is always open.
Okay, no.
Union 1 comma 2. Union 2 comma 2. And so on. The last natural number even I don't know. So that I am calling it as some n and so on. N comma union n comma n. N is don't include n because n is natural. So it is the union of all open intervals. You know that every point of an open interval is an interior. So we cannot write this as minus infinity to infinity, we cannot write. We cannot write. Why we cannot write it as minus infinity to infinity? Starting point minus infinity and but in between 1 is not included, 2 is not included, some points got excluded. So we cannot write it as minus infinity comma infinity. But it is a union of all open. So here we know that for an open interval, every point of it is an interior. It is also an interior point. Every point inside. Every point inside is interior point. Every point inside is interior point. Therefore, every point of R minus n is an interior point. Therefore, R minus n is also an example of a set in which every point is interior. All of you, is the argument clear now for all of you?
Yes, ma'am.
How the question comes in the entrance? How the question comes in the entrance? If R is S equal to R, S interior is. If S is equal to R, if S is equal to R, take this point 1. If S is equal to R, then S interior is. Then S interior is. What is S interior? R. For R, interior is itself. Because every point of it is an interior point. Next point. Next problem. All these are questions in the entrance. Some entrance are the other. If R is, S is R minus n, then S interior is. Then S interior is equal to R minus n. So for R minus n, interior is R minus n. For R, interior is R because every point of it is an interior. For closed interval, open interval. For open interval, open interval. Semi-closed also open interval. For N, interior is empty side. For Z, interior is empty side. For Q, S interior is empty side. For R minus Q, interior is empty side. Is it clear for all of you? How the question comes? We ask to find the interior of this. Interior of the set is. We ask somehow this topic, even if you miss now, again when you go to your MSc courses, again this is there. Even if you leave it here, it will be at the back of unless and until you settle down in your After settling down also, if you become a teacher, again same problem. Yeah, whenever this question comes, again you need to learn. Then nobody will be there to teach. And you cannot go and ask anybody else. After a certain stage, you cannot go and ask anybody else. We cannot go for tuitions then. Nobody will be there to teach for us after certain stage. Is that not? So, you should be very, very careful, particularly with this topic. Now, a set which is in the neighborhood of each of its points is R and R minus n. And interior is R minus n, S interior is R. A set which is
Excuse
not
me,
an
ma'am.
tell me.
Ma'am, can we say R minus Z is in the neighborhood of each of its points?
R minus Z.
Yes.
You can. Write that off. What is R minus Z? Write down that point. What is R minus Z? From minus infinity. That means it includes even negatives also. Minus 1, minus 2. What is this negative integer? Last one, call it minus n. Here 1, here 2. What is the last one we are calling n? Last one is n. So how to write R minus n from real number system? Remove integers. That means remove minus
शर्मा काकाचा फोन आला
minus 2,
काही
minus
नाही
1,
बोललो नाही झोपून आहे
2, 1, n. We have to remove. Then what are we going to get? Note down this. R minus n is minus infinity to minus n union and so on, union and so on, and so on, minus 2, minus 1, union, minus 1, 0, union. Earlier we did not consider negative because in natural number system negative not there. But in integers that is there, so we need to include that part also. Union 0 to 1, union 1 to 2, and so on, and so on, n comma infinity. Earlier we have taken only this part because 0 is not a natural number, minus 1 is not a natural number. So we have taken overall minus infinity to 1 total together. The total slot we have taken. But here we need to write even negative also. So minus infinity to minus n, union and so on, minus 2, minus 1, union, minus 1, 0, union, 0, 1 and so on up to n comma infinity. This is R minus n. You know that every point of open interval is an interior point. So every point here is interior, every point here is interior, every point in this interior and so on. Therefore, what is R minus Z interior? R minus Z. So every point of R minus Z is an interior point. You can also say R minus Z is in the neighborhood of each of its points. So example of a set which is in the neighborhood of each of its points. Also, example of a set which is not an interval and is neighborhood of every point is R minus n. They are union of intervals, but they are not intervals. You cannot write this as a comma b or some language because in between gaps are there. If you once you include minus infinity plus infinity, you must include all. But we have excluded minus 1, minus 2, minus 3 and so on, minus n, 1, 2, 3 and so on up to n we have excluded. So, R minus Z is union of intervals, but it is not an interval. R minus n is also union of intervals, but it is not an interval. So, example of a set which is not an interval and is neighborhood of every point of interval. Example is R minus n and R minus z. R we cannot say. R is a set as well as an interval also. Because R is the open interval minus infinity. But if you are asked to find what is the example of a set which is in the neighborhood of every point, but it is not an interval, it is is nothing but r minus n and r minus n. Okay, so note down this point now. Example of a set. Take the next point. Example of a set which is not an interval. Example of a set which is not an interval, but it is in the neighborhood. Of each of its points. But which is in the neighborhood of each of its points is. Example is r minus n. First example. Number 2, r minus n. These two are examples which are not intervals, which are union of intervals but not interval. But it is in the neighborhood of each of.
But it is in the neighborhood of
each of its points. Shall I repeat? Example of a set which is not an interval but in the neighborhood of each of its points. But in the neighborhood of each of its points is. Example. First, number 1, r minus n. Number 2, r minus n. Below that, write down another node. Take this as a node. R minus n, comma r minus z are union of intervals. But not an interval. Union of intervals, but not an interval. Union of intervals, but not an interval. Union of intervals, but not an interval. Emma? Let us see. So, union of intervals need not be an interval. That is also one thing we can infer. Next. Now, next one. A set which is not an interval. Just now I have given r minus and r minus z. One more. A set which is not an interval, but is a neighborhood of each of its points. One example we have seen r minus n, r minus z. But now you can also have union of intervals. R minus z, r minus n are also union of intervals. So here also, this is also an example. You know, open interval is denoted like this, or it is also denoted like this. So this is also an example. It is not an interval. You cannot write it as 1, 4. You cannot write because 2 to 3 not there. So here 1, 2, union 3, 4. So how will you represent this as a set? When you plot this on the number line, this is 1, 2, this is 3, 4. 1, 2, 3, 4. So union of 1, 2, 3, 4 means all real numbers here, all real numbers here. But 1, 4 means we have to include from here to here total. But 2, 3 is not included. So we cannot write it as 1, 4. We cannot write it. So it is union of intervals. You know that every point inside this is an interior point. Because if you take a neighborhood, it will be inside this. P minus epsilon, P plus epsilon will be inside this. Take any point P here, then P minus epsilon, P plus epsilon will be inside this. Therefore, every point of this is an interior point. So, every point in this is an interior point. Every point in this is an interior point. Therefore, every point of overall is an interior point. But this is not an interval, but it is having every point of it as interior. Emma, is it clear for all of you? What is S interior for this? Note down this point. Note down this. If S is equal to, note down this. If S is equal to R minus N, then S interior equal to R minus N. Very important. S equal to R minus N. S interior is R minus N because every point is interior point. Next, if S is equal to R minus Z, then S interior is R minus N. S equal to R minus Z. S interior is R minus Z. Next, if S is equal to to 1, 2 union 3, 4. If S is equal to number 3, 1, 2 union 3, 4. Then S interior is itself 1, 2 union 3, 4. Emma. Next, somebody may get it out. Take this. Suppose you are given if S is equal to, next take down another problem. If S is equal to closed interval 1, 2 union 3, 4 closed, then S interior is
Open interval.
for closed 1, 2. What is the interior? Open. Because 1 is not interior point, 2 is not interior point. Union. 3 is not interior, 4 is not interior, but every point inside is interior. So whenever closed intervals are given, you remove closed, make it open. That will give you S interior. Is the application clear now?
Yes, ma'am.
Because whenever endpoints are there, endpoints are never interior points. Remove them because S interior means all interior points. Suppose somebody may get it down. Take another one. S is equal to closed 1, open 2. Union. Open 3, closed 4. Let us see. Then S interior is.
Open union.
Open interval 1, 2 union, open interval 3, for semi-closed also you will get same. Interior is same, but sets are not same. You might have observed, for closed interval also interior is open interval. For open interval also it is open interval.